First images from the largest camera ever built reveal millions of galaxies. The first test images from a groundbreaking observatory named for trailblazing astronomer Vera Rubin have captured the light from millions of distant stars and galaxies on an unprecedented scale and revealed thousands of previously unseen asteroids. While the National Science Foundation initially released only a couple of images and a brief video clip of the Vera C Rubin Observatory's first imagery, more images and videos taken using the largest camera ever built were shared Monday on the agency's YouTube channel. The facility is jointly funded by the National Science Foundation and the Department of Energy's Office of Science. The new images represent just over 10 hours of test observations, offering a brief preview of the observatory's decade-long mission to explore the mysteries of the universe like never before. NSFDO Rubin Observatory will capture more information about our universe than all optical telescopes throughout history combined, said National Science Foundation Chief of Staff Brian Stone, who is currently performing the duties of the NSF Director as the position is currently vacant. A stunning first look among the observatory's initial accomplishments was the discovery of 2,104 asteroids, including 7 near-Earth asteroids, that have never been seen before in our solar system. None of the newly found near-Earth asteroids pose a risk to our planet, according to scientists at the observatory. Imagery of the asteroids can be seen below. While ground and space-based telescopes spot about 20,000 asteroids each year, Rubin Observatory is expected to uncover millions of the space rocks within its first 2 years, according to the National Science Foundation. The telescope is also considered the most effective way to spot any interstellar comets or asteroids that may travel through our solar system. The observatory's mirror design, sensitive camera, and telescope speed are all the first of its kind, enabling Rubin to spot tiny, faint objects such as asteroids. The observatory will also constantly take thousands of images every night, cataloging changes in brightness to reveal otherwise hidden space rocks, like near-Earth asteroids, that could be on a collision course with our planet, according to the Foundation. A sneak peek shared Monday, seen above, includes a video made from over 1,100 images captured by the observatory that begins with a detailed look at 2 galaxies. The video then zooms out to showcase about 10 million galaxies spotted by the camera's wide view, roughly 0.05% of the 20 billion galaxies Rubin will observe over 10 years. The observatory team also released a mosaic of the Trifid and Lagoon nebulae, which are star-forming regions that resemble clouds located in the Sagittarius constellation. The mosaic, made up of 678 separate images taken over just 7 hours, captured faint and previously invisible details such as clouds of gas and dust in the nebulae, which are several thousand light-years away from Earth. The initial images were selected to showcase the telescope's enormous field of view, which enables detailed glimpses of interacting galaxies as well as broad views of millions of galaxies, said Dr. Yusra Al-Sayed, Deputy Associate Director of the Data Management Subsystem for the Rubin Observatory. It has such a wide field of view and such a rapid cadence that you do have that movie-like aspect to the night sky, said Dr. Sandrine Thomas, telescope project scientist for the Rubin Observatory. The observatory, located in the Andes on the top of Cerro Pachón in Chile, is nearly complete after about 2 decades of work. The facility is set to achieve first light, or make the first scientific observations of the southern hemisphere's sky using its 8.4-meter, 27.5-foot Simone survey telescope. On July 4th, the telescope's location in the southern hemisphere allows for a great view of the Milky Way's galactic center, said Edward Ajar, Rubin Observatory's program officer. The region in central Chile has also been home to other ground-based observatories and is favored for astronomical observations because it affords dry air and dark skies. The observatory's main objective is the legacy survey of space and time, an ultra-wide and ultra-high-definition movie of the universe made by scanning the entire sky every few nights over 10 years to capture a time-lapse compilation of whizzing asteroids and comets, exploding stars, and distant galaxies as they change. The survey is expected to begin between 4 to 7 months after first light. Rubin will enable us to explore galaxies, stars in the Milky Way, objects in the solar system, and all in a truly new way. Since we take images of the night sky so quickly and so often, it will detect millions of changing objects literally every night, said Dr. Vera Rubin, professor of particle physics and astrophysics at Stanford University's SLAC National Accelerator Laboratory in California. Rubin was responsible for the assembly and testing of Rubin Observatory's car-size camera, which is capable of capturing a breathtaking level of detail. One Rubin image covers an area of sky equal to 45 full moons, said Zeljko Ivezic, Rubin Observatory director. To properly display the observatory's full field of view, 400 high-definition televisions would be needed to show just one Rubin image, Ivezic said. The observatory's website enables visitors to zoom into one of its images, called the Cosmic Treasure Chest, to truly appreciate all of the details, as well as hear the cosmos as Rubin does through soundscape technology. Solving cosmic mysteries. Rubin's capabilities to spot interesting phenomena will also enable it to be a discovery machine that can identify interesting areas of focus for other telescopes, Rubin said. The observatory could also enable the detection of previously unknown types of celestial objects. The telescope's namesake, considered to be one of the most influential women astronomers, provided some of the first evidence that dark matter existed. In Rubin's honor, the telescope is expected to continue her pioneering work. Through this remarkable scientific facility, we will explore many cosmic mysteries, including the dark matter and dark energy that permeate the universe, Stone said. Dark matter is an enigmatic substance that shapes the cosmos, while dark energy is a force that accelerates the expansion rate of the universe, according to NASA, though they are thought to make up most of the cosmos. Both are impossible to directly observe, but can be detected due to their gravitational effects. Rubin has enormous potential to help us learn what dark energy really is and how the universe's expansion is accelerating here, too, Rubin said. Rubin's unique ability to see billions of galaxies and to image them repeatedly over 10 years will literally enable us to see the universe in a new way.